As John said earlier on, technology is changing. And even nowadays, the materials that we have are changing also. So I want to talk to you about a memory that has, an alloy that has memory, meaning it's able to think a bit. The name of the alloy is nitinol. It's made from nitide, nickel, and titanium. So I'll have samples just for demonstration because I know seeing is believing. Now, if I have these two materials, one of them is stimulus responsive. What it means is that it is able to react to the environment. This is a typical steel spring. What it does is that once I stretch it over a certain period, it cannot recover. Most of the time, we've dealt with this type of materials, but currently, there are materials that are able to remember their shape. And to see applications of these materials, we need people like you to be able to come up with ideas where we can apply these materials. So what happens is this material, once it is trained, meaning we can force it to remember this shape that I have in my hand here. If I deform it, what will happen is that it will not go back to the original shape, but since it has been trained to remember its shape, I'll put it over a certain temperature, so meaning it is heat activated. There are some of them that are magnetic activated, electrical activated. So what I will do, this is just hot water. Sure, that would be great. So what I will do, since the material is designed to remember a specific shape, once it gets into contact with hot water, it just remembers that original shape. So this is what we call the shape memory material or shape memory alloy. You can do it several times. For instance, I have the same type also. You can do it several times. If I take it out, because it's hot, I don't want to put my finger in it. If I take it out and stretch it again and put it back, so far as it is set to remember the shape, it will always go back to that shape. This is another sample, the same spring type. If I stretch it, you can make it as, probably I should have called a student to do this. Now, if I put it back here, thank you. Go ahead. It just remembers the shape. Now, it does not mean that the alloy remembers only spring shapes. It can be set in any type of shape at all. The process behind this is what we call the phase change, meaning the alloy can exist in the austenite and martensite state. In the high temperature state, the alloy is very hard and rigid. Then in the low temperature state, it is very soft. So when it's soft, I can deform it. Then once I make it cross a certain transition temperature, it is able to go back to the shape that I trained it to remember. We have what we call the one-way shape memory effect. If you see the alloy that we have, what happens is it is set to remember just one shape. We can train it to also remember two shapes, meaning it can remember a shape when it is cold and it can remember a shape when it is hot. That is what we call the two-way shape memory effect. Then we have pseudo-elasticity. As I explained to you, if you take a steel spring and you stretch it over its elastic limit, it cannot go back. It deforms. So if you stretch this, even if I put it in hot water, it won't go back because it is a different material. But the pseudo-elasticity can be stretched and it still goes back to its original shape. Because of these unique features, there are several applications in the aeronautics, automotive, biomedical, and civil engineering. I will just show you a few of that. If I take the self-expanding stent, so in this, we have a stent that is made from nitinol. What it does is that the stent is designed to memorize the first configuration. So if I crush it, then put it in a catheter and deploy it in a part of the artery that is plagued, what happens is that once it gets close to the body temperature, it will try to go to the configuration that it has memorized. By so doing, it is able to expand and open the artery for blood to flow. The other application is the bone staple. If you are into sports, maybe one time, or maybe you have experienced this already, there could be fracture in your bone. If there is a bone fracture, we need to ensure that the parts that are fractured come close into contact, because that is how healing will occur. So we can have a bone staple, which is designed to remember the configuration here. Now, once we deform it and insert it into the fractured part, what will happen is that as the staple gets into contact with the body and it begins to become warm to the 37 degrees Celsius, it begins to close again. By so doing, it exerts compressive forces, helping the fractured joints to come close to each other. I'll show you just a short video about that. So this is the configuration that is memorized. Now we open this configuration, meaning the shape is now deformed. We will bring it to the part where there is fracture and insert it. As it gets hot, or to the 37 degrees Celsius, which is the body temperature, what will happen is that it will try to bring the two fractured joints together. That is shape memory effect. In terms of actuation, there are micro actuators that can be designed to operate in the two-way shape memory effect, meaning they can be designed to remember shapes at the hot temperature time, then the cold temperature time also. So this is a typical type of micro gripper, and this is designed to hold a piece of optical fiber. This is very small. Now, how this operates is that if it is set to remember a certain shape, so once I heat it, it is going to open. Then once I cool it, it is going to close. So you can see that this is the heating. It is going to close, hold the thing. Then once I cool it, it is going to open. And this has nothing to do with mechanical forces. It is just the material responding to changes in temperature. The last application that I will show here is what we call the rock splitter. And it is designed by NASA Glenn Research Center, which is just close by here in Cleveland. Here, what we have is that the splitter is designed to expand after a certain temperature. So if we make a hole within a rock, then we insert the splitter because it wants to expand through heat activation. By so doing, it will try to crack the rocks. So these are some of the materials that are being invented. These are not the only ones. But as I said, it takes people like you to be interested in materials like this, to see several applications of this. This material can be applied also in civil engineering. If I'm designing against earthquake and I have small component of the shape memory alloy, because the alloy is able to always go back to its original configuration, it forces buildings to go back to their original state even after earthquake exposure. So you can see here, we have two materials exposed to the same earthquake effect. One of them is made from the shape memory alloy, which is in blue. Then after several cycles, what happened is that it came back to the original state. But for the other material, it shifted. So it means that there are several applications that we can use this material for, but it needs people like you to be interested in doing that. Now, if you have any questions, I would take that from you.